Our experiment was to see how the temperature of water affects dissolving. Before we started, we had to make a prediction using scientific ideas based on particles about what would happen. And after having a quick go at the experiment, we had to write a method which said the correct way to carry out this experiment. First, we'll concentrate on what gives a good mark for your prediction. Here is a level ladder. The higher up you go, the more marks you get. So at the beginning, you just have to say whether sugar is likely to be soluble and give a reason. To be more scientific, you need to give a reason that uses particles in your answer. So particles of water move apart, which allows dissolving to take place. Even higher, labeled diagrams score the most marks for this task, and the idea of a saturated solution is probably left until you're a bit older. This picture from the internet helps show the idea of sugar dissolving. Yours needn't be as complicated as this one. It's the last picture on the end you'd need to focus on. That when the sugar cube is put into water, eventually the particles spread out more and more as they get smaller and find all the gaps between the water particles. When the sugar's disappeared, we say it has dissolved. Next, we'll concentrate on the method. So the prediction can go up into the corner here. Here's a level ladder for the method. In science, we like you to make numbered steps that can be followed. So as you can see, giving 3 or 4 steps increases your marks, and also you should add some detail like how much water should be used in your method. The idea is that as your method gets better, so anybody else will be able to follow exactly what you did. So your method would read something like: first collect the apparatus, then put 50 centimeter cubes of water in a beaker using a measuring cylinder. Check the temperature of the water with a thermometer. Start off with cold water. Add a sugar cube and start a stopwatch to see how long it takes to dissolve while stirring with a glass rod. Repeat the whole experiment again using water at a higher temperature. Finally, add your results, and this will be the time for dissolving in seconds, to a results table, and we look at that next. Our results are normally put in a table with 2 parts, and in this case we've got temperature, and we'll say cold and hot, and time in seconds. I'll make some times up. I'm going to say 75 seconds for cold and 25 seconds for hot. That's the time taken to dissolve. The next task is to plot a graph of these results. Mark out an axis with a pencil in both directions. Label each scale. Mark out the vertical scale for time, with each gap standing for 5 seconds. Next, we indicate where the bars on our graph are going to be. Finally, we try and get the height of our bars correct. So cold has to reach 75 seconds, and hot will be 25 seconds. That's it, done. At the end of all experiments, you're asked to give a conclusion, and in this case it was, what's the difference between the 2 times involved. You're also asked to give a scientific idea which explains the conclusion. Why is water, when it's cold, taking longer to dissolve sugar compared to when it's hot? And this is your second chance to go back and have a look at the scientific ideas. Remember, when water particles are cold, they move slowly and are close together. when water particles are hot, they move very, very fast and create more spaces. So the sugar can fit into these spaces more easily.